Hi everybody, Patrick here from Engineeringshock.com, electroniclessons.com, and paintballprops.com. For those of you who supported my last Kickstarter, this is your assembly video. This is for the 10-bit infrared learning board processor set. We'll be discussing how to assemble version 2 first because it's smaller and easier to assemble, and version 1 soon after. So we're going to quickly go over the components, and then we're going to assemble it piece by piece. So this is the final board, the version 2. This is how it should look when it's all done. And what you'll get for a kit is an empty PCB, momentary push switch, 2 100 microfarad electrolytic capacitors, an infrared receiver, a programmed microcontroller, 18-pin, an 18-pin dip socket, 2 0.1 microfarad ceramic capacitors, a 78L05 5-volt regulator, 4 2-pin headers, a 13-pin header, a 20 kilo ohm resistor, a 100 ohm resistor, 4 10 kilo ohm resistors, a power jack, and 3 header jumpers. So first of all, let's connect all of our resistors. The 6 resistors included are, again, 4 10k ohm resistors, a 20k ohm resistor, and a single 100 ohm resistor. And the 100 ohm resistor goes in the R1 slot right here, labeled 100R, 100R. Make sure that if you can't read resistor color code, that you use your multimeter to determine which resistor is which. Place your 100 ohm resistor in the R1 slot. R2 is your 20k ohm resistor, labeled R2 2OK, so 20k. Make sure that you place that specific resistor in this slot. R6, R4, and R3 are all labeled 10k, so place 3 of your 10k ohm resistors in R6, R4, and R3. Lastly, R5 right here is also labeled 10k. R5, 10k. Place your last 10k ohm resistor in that slot. They are not polarized. They can go in either way as long as you're placing the correct resistor in the correct slot. So solder those into place, and next we'll do the capacitors. There are 2 types of capacitors, ceramic and electrolytic. The ceramic capacitors have 2 equal size leads, whereas the electrolytics have a long lead and a short lead. Let's do the ceramics first because they're both the same value, as are the electrolytics, but they are not polarized. So you can place them in either way as long as you place them into the correct slots. So they are both labeled 104 on the actual capacitor themselves, and that indicates that they are 0.1 microfarads. Now, they go in the C4 slot and the C2 slot. Place them side by side. Make sure that make sure that when you solder them into place that there are no shorts. Again, because there's no polarity, you can place them in either way as long as they are correctly inserted into the slots and that there are no shorts. The electrolytics, a little bit more complicated, but you won't have any problem with it as long as you follow along with this video. The electrolytics go in the C3 and C1 slots, and they're both labeled 100U for 100 microfarads. Now, in the C3 slot, you probably can't see it from this angle, but the left hole has a little plus sign just above it, very, very small. You want to place the long lead of the capacitor, the positive lead, into the left hole of C3, and the short lead into the right hole of C3, and you want to solder it into place. Now, if you reverse those leads and you power it up, expect the capacitor to pop, and your circuit will become more or less useless, potentially. There might be a short inside. There will certainly be no filtering, or rather smoothing of the power supply, and that will mess up your circuit. You want to make sure long lead, left hole, short lead, right hole. Same thing goes for C1. Again, they're both 100 microfarads, so you can use either capacitor as long as they go into the C1 and C3 slots. In the case of C1, the positive sign, the little plus sign, is just below the right hole. So place the long lead in the right hole and the short lead in the left hole. Solder them into place. Double check the polarities before you solder them. These are the most complicated components to solder to the entire board, specifically because you have to be very, very careful not to mix up your polarity. In any case, next we will do all of our header connectors. Easy step. Your 4 2-pin headers go in the EN slot right here, the PG slot right here, the A slot right here, and the B slot right here. The 13-pin header connector goes in the 13-pin header slot right here. Now here's the neat thing. If you want to be able to place this into a breadboard, you can place the long leads facing down and the short leads facing up from the bottom of the board. Then you can just plug it into a breadboard. Commonly what I would do is solder the long leads facing up. But it is up to you. You have that option. I'm going to solder it like this. But you can solder it from the bottom if you'd like. The button. The button's very easy. It fits in only one way, and it pops right into place. So line up the holes, pop it into place, and solder the 4 leads on the bottom of the board. Make sure that the button is flush to the board when you are soldering it into place. The power jack only fits in one way. There are 3 leads. The DC jack hole faces outside to the left of the board. Make sure that you don't apply too much heat to each hole at a time or else you'll melt the plastic. Just make sure that there are connections on all 3 holes. And again, you want to make sure that it's flush to the board. Lastly, the 78 LO5. 78 LO5 goes in the IC3 slot right here. And you'll notice that the front is curved, or the front is flat, and it says 78 LO5 on it, and the back side is curved, which is why I'm tilting it right now. It's curved on the back. On the footprint, the back is curved, and on the front of the footprint, it's flat. You want to make sure that from a bird's eye view, you line up the front flat side of the 78 LO5 to the flat side of the footprint, and the back, which is curved, to the back of the PCB, the curved side of the footprint. If you reverse that, your device will not regulate to 5 volts. So solder those into place. Next we'll do our socket and our infrared receiver. The socket is easy. One thing you want to know about the socket is on the footprint, there's a little notch on the left-hand side from this perspective. On the socket itself, there's a little notch on the left-hand side. Make note of that when you're placing it in. You want to make sure that the notches face each other from a bird's eye view. So in this case, the notch has to face left. Pop it into place, make sure it's flush to the board, solder it in, make sure there are no shorts. And once you've done that, you can take the chip. And what you'll notice about the chip is that there is a notch on the left-hand side. You want to make sure that the notch fits into the socket facing left from this perspective. If you turn the notch around and you place the chip in incorrectly, in the wrong polarity, say goodbye to your chip and to your project. If you do that, you can get a replacement chip, but it's going to inconvenience you greatly. So make sure that all of the notches are facing left from this perspective. The infrared receiver has 3 pins. The back side is just a piece of metal. Front side has a little infrared sensing window, and that goes in the slot right here. There's 3 pins. Make sure that the window is facing towards you from this perspective. Place it down to the board. It can be a few millimeters up off the board if you'd like. I'm going to place it not flush, but about 2 millimeters above the board, facing the front of the board from this perspective. What you'll notice is I've taken our 3 header jumpers. I've placed one over the EN header, and I've just held these 2 here for safekeeping. The manual link below tells you how to work the board. So we're going to solder these last 2 components in, have a look at it, determine if everything's okay. And we're done. I've placed the chip, notch to the left, bottom of the board, no shorts. Very, very important that you double check for shorts before you power it up for the first time. And the video link below shows you how to test and use this specific module. Now let's talk about how to assemble version 1. This is the version 1 kit. You got your custom PCB, power jack, 2-pin terminal block, 18-pin DIP socket, 18-pin programmed microcontroller, 6 10k ohm resistors, 6 470 ohm resistors, 1 100 ohm resistor, 1 20k ohm resistor, 2 5-volt relays, 2 3-pin terminal blocks, 2 1N4001 diodes, 2 0.1 microfarad ceramic capacitors, 2 100 microfarad electrolytic capacitors, a momentary push switch, 6 2-pin headers, 5 2-pin jumpers, a 13-pin header connector, 2 2N2222 NPN transistors, an infrared receiver, 7805 5-volt regulator, and 11 3mm red LEDs. The first thing we're going to do is connect our resistors, and then we're going to do our capacitors and diodes. Again, we have 6 10k ohm resistors, 6 470 ohm resistors, a 100 ohm resistor, and a 20k ohm resistor. R5, R3, R4, and R6 are 10k. They're labeled 10k. R7 is also labeled 10k, and R8 is also labeled 10k. So place all your 10k ohm resistors in those slots. They're not polarized, so don't worry about it. Just make sure that you have the right values in those slots. R7 is your 20k ohm, R2 is your 20k ohm resistor. R1 is your 100 ohm resistor labeled 100R. Your 6 470 ohm resistors go in the R9, 10, 11, 12, 13, and 14 slots. So the resistors are very, very easy to populate. Solder those all into place, and next we'll do our 2 power diodes, our electrolytic, and our ceramic capacitors. First of all, let's talk about the 2 diodes. The diodes have 2 leads. The leads are the same size, but to determine the polarity, there is a black side of the diode itself and a side with a white stripe on it. The side with the white stripe on it is the negative, or cathode. The side with the black is the anode, or positive. And so we have got 2 of those to solder into place, and they go into the D1 and D2 slots. Now you'll notice on the D1 and D2 slots that there's a white stripe on the lower edges here. That tells you that the negative pin, the cathode, should be soldered to that specific hole. So in both cases, place your side with the white stripe, cathode, to the lower holes, and the positive with the black stripe, the anode, to the top holes. Don't reverse those, or if you turn the relay on, either the relay is on in operation, you'll basically reset the entire circuit. Very, very, very important. Next, the ceramic capacitors. The capacitors themselves are labeled 104. That is an indicator to tell you that they are rated for 0.1 microfarads. They're both ceramic. They have equal sized leads, which means that they're not polarized. They go into the C4 slot right here, and the C2 slot right here. They're labeled 0.1U for 0.1 micro. The 2 electrolytics. Now pay close attention. The 2 electrolytics, there is a positive and a negative lead. The longer lead is positive, the shorter lead is negative. And they go into the C3 slot and C1 slots. Now, on the C3 slot, there is a plus sign above the top hole here, the hole facing the top of the board. That's your positive lead. It's very hard to see on camera, but look for that little plus sign. You want to place your long lead in the top hole next to the plus sign, and your short lead on the bottom hole facing the bottom of the board. You want to place your negative lead there, your short lead there. If you turn it around and you turn it on, your capacitor is likely going to blow. Be very, very careful. Double check it before you solder it. In the case of C1, the little plus sign is on the lower right. Again, very, very difficult to see from on camera. Even here, you want to be very, very careful to look for it. It's very, very small. So place your long lead in the right hole and your short lead in the left hole. Again, if you power it on with, if you've soldered it in incorrectly, you've reversed the polarity, you power it on, poof, you've let the smoke out. Be very, very careful of those components. Very specifically the electrolytics and the diodes, because if you solder them in backwards, it's going to be bad news. Next, we will do our LEDs and our transistors. We're also going to do the button in this step. The button goes on to the cell footprint. It only fits in one way. Once you've lined up all 4 holes, pop it in. Make sure it's flush to the board when you solder the 4 holes in the bottom. It's very easy. A very easy component to, and it should pop right into place as long as you have the 4 leads lined up properly with all 4 holes. The 2 transistors. What you'll notice is that there's a curved side to both of the transistors. Curved side, as you can see, this one is pivoting on its curved side, and then there is a flat side. The flat side has writing on it, and it should say 2N2222, and that will tell you that it's one of our transistors. The 2N2222 NPN transistors go in the T1 and T2 slots. You want to, from a bird's eye view, make sure that the flat side with writing on it faces the flat side of each footprint, which is to the right of the board, and that the curved side, from a bird's eye view of the transistors, the curved side faces the curved side of the footprints. So in other words, the side with writing on it faces the right side of the board, the curved side faces the left side of the board. If you turn that around, your relays won't work. So be very, very careful when you're soldering those into place. Also make sure that there are no shorts when you're soldering them into place, because the holes are relatively close to one another. There are 13 LEDs, 13 3mm red LEDs. I'm only showing two right here. And what you'll notice is that they've got a long lead and a short lead. Long lead and a short lead. Similar to our electrolytic capacitors. And they all go in these slots up here, labeled in for indicator 9, 8, 7, 6, 5, 4, 3, 2, 1, and 0. Those are our indicator LEDs. So each of them has a positive and negative. All of the positives go in the bottom hole. All of the negatives go in the top holes. So the indicators on each of them, again, here, for instance, here 0, here 4, here IN. The top side is where the indicators are, and the top side is where all of the negatives are. So all of the short leads go into the top holes, and all of the long leads go into the bottom holes. So, for instance, our indicator, our IN LED, I'm going to place my long lead, hopefully you can see that, my long lead in the bottom, my short lead in the top. And I'm going to place it flush to the board and solder that into place. Then I'm going to take another LED, take the long lead, place it in the bottom pin for 9, and the short lead in the top pin. Solder that into place, and I'll be doing that for all of the LEDs. If you mix up the polarity when you place them in, that LED will not work. So be very, very careful. Get a good solder joint. Don't apply too much heat, and you won't have any problems. So solder all of those components into place, and next we will do our header connectors. The headers are easy. Your 13-pin header goes on this header socket here, and voila. Just make sure that there's no shorts when you solder it and that the header is facing 90 degrees. The 2-pin headers go in these 6 slots right here, labeled A, B, PG, R2, R1, and LED enable, or LED_EN. Solder those all into place. Make sure that there's no shorts whatsoever. Otherwise, you might have problems with your circuit. Once you're done that, we will do our socket and our terminal blocks. The socket. What you'll notice on the footprint, labeled IC1, is that the 18-pin socket has a little notch on the left-hand side. There's a notch on the left-hand side of the socket. For a bird's eye view, make sure that the socket notches on the footprint and on the socket itself line up. Place into the board. Make sure it's flush. Solder all 18 pins. Make sure that there are no shorts. Double check afterwards to make sure that there are no shorts, or else your circuit might not function properly. Will not function properly. Once you're done with that, what you can do is, if you notice on the chip, there is a little notch on the left-hand side of the chip. From a bird's eye view, make sure that the notch on the chip faces the notches on the left on the footprint and on the socket, or in other words, facing left from this perspective. Carefully insert the chip into the socket after you've soldered the socket into place. There are 2 3-pin terminal blocks and a single 2-pin terminal block. On one side, on all the terminal blocks, it's just plastic. On the other side, you've got 2 screw-in terminals. Make sure that in all cases that the terminals face outside of the board. When you're soldering them into place, use a healthy amount of solder, and make sure that they are all flat to the board. They are all flush to the board before you solder them in. Very, very important. You don't want them facing inside the board, or else you won't be able to solder or to connect anything to it. So solder those components into place. Then place your microcontroller into the socket as we just discussed. Next we will do the regulator, the 7805 5-volt regulator, the infrared receiver, and the power jack. And after that we'll finish off with our 2 5-volt relays. The 7805 5-volt regulator has a front side with black on it in writing. The back is simply white or grayish. From a bird's eye view, you want the front black side with writing on it to face the bottom of the board. Place the regulator as far down on the board as it will go. Make sure that it is flush when you solder it. As well, it can be difficult to solder the 7805 without shorting to each other. Be very careful that after you've soldered, that the solder joints are clean and that there are no shorts between the 3 pins. The power jack has 3 pins. You can only solder it one way, with the connector facing outwards to the board. Make sure that it's flush and that you do a healthy amount of solder on each of the 3 pins. Don't leave your soldering iron on the leads for any long period of time, or else you'll melt the plastic. Be careful of that. The infrared receiver has a window on one side and just metal on the back. Make sure that the window is facing outwards when you place it on this 3-pin footprint right here. Place it about a millimeter above the board, so you have about a millimeter left of leads. Should fit right on the board. So after we're done that, we're going to have a quick look at the board before we solder our relays on. Final step, I've taken one of my 2-pin headers and I've shorted the LED EN pins so that the LEDs have been enabled. Make sure to find a safe place for the remaining headers, or jumpers rather. Your 2 relays, they have 5 pins on them, 3 on one side, 2 on the other. They only fit into the footprints one way. They should pop right in. Make sure they're flush to the board, and then you get a healthy amount of solder on each of the 5 pins. Do that for both relays, and once you're done, we'll look at the top and bottom, and that'll be it. And we're all done. That is how the bottom of your board should look like. Give or take, everyone's soldering skills is a little bit different. So thanks for watching. The manual is below.